All right, this video is for December 1st. So lesson is the 17.2 using tables in the substitution method. Sort of and to what we have been a little bit of a different method for today. Okay, so the first question talks about how we've been doing graphing to solve. And in addition to graphing, you can also look at a table to find an answer and look for an ordered pair that's common to both equations. So on the calculator, I'm going to do my y equals and graph this first one, 450 minus 60h. And I'll do 60x instead of the h. When I click on table here, I can copy down those values. So 0 goes with 450 and 1 goes with 390. 2 goes with 330. 3 goes with 270, and 4 goes with 210. Okay, we're going to do the other table as well. So back to your y equals 60x plus 90. So I'm graphing the second one now, and I'll click on that table again. The 0 goes with 90. 1 goes with 150. 2 with 210. 3 with 270. And 4 with 330. What ordered pair do the two equations have in common? So 0, 450 and 0, 90, 1, 390 and 1, 150, 2, 330, 2, 210, 3, 270 and 3, 270. So this ordered pair is in common on both charts. So 3, 270. Feel free to pause and go back as needed. On our second page, it says graph the equations on a graphing calculator and identify the solution. So I'm going to be using the calculator app just because that's what I have right now. You can use the yellow calculator. I think the steps would still be written on the board. So we have our 450 minus 60x. That's the first one. And then the second one, our second one is 60x plus 90. 60x plus 90. So when we hit graph, and you would be doing the Zoom 6 if you're on the yellow calculator. I'm going to zoom out. You know what? Zoom 6 is not going to be helpful for this question because the numbers are so big. So maybe the iPad app, if you want to stay with me on the iPad app. We can see the intersection. And if you tap that intersection, it'll kind of come up and say the intersection is 3 and 270. So it's the same point that we saw in common in the tables. 3, 270 is also the intersection. Number 6, is it possible the intersection point from a graph of a linear system does not show up on a table? So we could say yes if the solution was a decimal. You probably wouldn't see it in the table because the table's just going 0, 1, 2, 3, and so on. How could we get the solution? We could graph on the calculator. So we saw that example yesterday where the solution was like 1.8 and 0.4. The calculator had no problem finding that intersection. So if you don't see it in the table, maybe it's a decimal, and we can graph it on the calculator and do our second trace. Number 5, enter, enter, enter. All right, the middle of the page, we're going to solve the system. So for number 7, I mean, this is a really easy one to do on the calculator. So if we go to our y equals 2x plus 6 and negative 3x plus 16. So in the table, we can see right here, 2 and 10 and 2 and 10. I know this looks kind of weird when there's two y charts, but the x is 2 and the first y is 10 and the x is 2 and the second y is 10. But you can also see it on the graph when you look at the graph. And I'm going to do a zoom standard. So when you see that intersection, 2 and 10 is the intersection. And then our last one, we do have to get the y alone. So we first have x plus y equals 8. We would need to do minus x, and we get 8 minus x. And then the second one, 3x plus 2y is 14. We would have to do minus 3x to get 2y equals 14 minus 3x. And then we would have to divide by 2, divide by 2, divide by 2. 14 divided by 2 is 7, minus 3 over 2x. Okay, 3 over 2 cannot be simplified. So we would just leave at minus 3 over 2x. So now that we have both of these equations, solve for y, we can look at those graphs, 8 minus x and 7 minus 3 over 2x. And let's see if we can see in the table again where it's matching up. Right here, negative 2 and 10, negative 2 and 10. And when you look in the graph, there's the intersection, negative 2 and 10. So that would be our solution. Of segues into a different method here. So it says sometimes it's difficult to solve a system of equations by graphing or by using tables of another solution method. This scenario again with Roy and Travis. Roy leaves Pecos 1 hour before his brother and is driving 55 miles an hour. Travis leaves Dallas during rush hour and is only going 45 miles an hour. And they give you the equations. So we don't need to write equations or anything like that. So the method that they're going to show you is called substitution, where if you take Roy's expression 450 minus 55h, this is equal to D. And so what you would be able to do is take this and plug it into the bottom where the D is. And so what you end up with is 450 minus 55h and 45h minus 1. And on Friday, we're going to be doing a lot of practice of these substitution problems. We won't be learning anything new on Friday. So we'll just jump into this algebra now of solving this equation. So we would first distribute. We have 450 minus 55h. 45 times h is 45h. And 45 times negative 1 is negative 45. Then we have some variables on the left and variables on the right. So I'm going to go ahead and do a plus 55h and plus 55h, leaving me with 450. 45 plus 55 would be 100. H minus 45. And then we have our variable here. So we're going to start to move everything away from it. And we would do a plus 45 and plus 45. Almost finished here. We have 495 is 100h. And then my very last step, I'm going to divide by 100 and divide by 100. And that comes out to 4.95 is h. Okay, pause as needed if you need more time. Then, let me see, did they just stop there? Yes. Okay, so they just stopped the question there. All right, so all right, so then they're naming that method now, I guess. Another method for solving systems is the substitution method. It's actually what we just did. One equation is solved for one of the variables, then the expression for that variable is substituted into the other equation. So we're not going to focus too much on the writing of the equations. I'm just going to really focus on like how to solve it. So here's a scenario: Valentine's Day dance. Tickets for couples are $12. Tickets for individuals are $8. 250 students attended the dance. 1580 was collected from ticket sales. How many of each type of ticket was sold? X is the number of couples. Y is the number of individuals. So don't worry too much about the writing of the equation part. Write an equation to represent the number of the people attending. So X is the number of couples. Each couple has 2 people. So we'll take the number of couples and multiply it by 2. We'll add on the number of individuals. That's your Y. And all together we have 250 people. For the equation to represent the money collected, the number of couples is X, and a couple is going to pay $12. So 12X, one couple would be 1 times 12, 2 couples is 2 times 12, and so on. Y is the number of individuals, and they're paying $8. So that would be 8Y. One person is 1 times 8, 2 people, 2 times 8, and so on. So this is the money that we've collected all together. Oop, don't want to do that. All together, we've collected $1,580. And then here's what we're focusing on. So like I said, don't worry too much about this writing of the equations, but how to solve it. So with our substitution method, we're going to take the top equation and we are going to solve it for Y. So we've been working on this for a few days now. We'll move over the 2X, minus 2X and minus 2X. And we have Y equals 250 minus 2X. Once you have that, once you have it solved for Y, you're going to take this. This is equal to Y. And you're going to substitute that into the second equation. So in other words, this is equal to Y, and we're going to put it into that equation for Y. Since it's equal to Y, it can replace the Y. And so what that step is going to look like, I have my 12X, I have my plus sign and my 8. And then instead of Y, I'm taking this expression that's equal to Y and I'm putting it where the Y is. And it would be in parentheses. And then equal sign 1580. So this entire expression that's highlighted yellow got plugged into that second equation for the Y value. And at that point, then you're just doing your algebra. So I'm just looking for where. Yeah, okay, so now we're going to solve it in this space right here. So we'll start with our distribution. So we have our 12X plus, and then let's see what this 8 times 250 is 2,000. 8 times negative 2X is negative 16X, and we get 1580. Then we have 12X and negative 16X that are on the same side of the equation. So 12X minus 16X is negative 4X, right? That's 12 minus 16 is negative 4. That would just be, right, 12 minus 16 is negative 4. So negative 4X plus 2,000 is 1580. And then we're going to continue solving. So we're trying to get the X by itself. Minus 2,000 minus 2,000. Negative 4X, 1580 minus 2,000. We get negative 420. And then our very last step would be divide by negative 4, divide by negative 4. and we get x is 105. The final thing, so x is the number of couples, and we just found out that that was 105. The last thing we'll do is we want to know what y is as well. X is the number of couples, that's 105 couples. Y is the number of individuals, and we want to figure out how many there were that attended. So what they're saying to do is you substitute 105 now for x. In other words, you can pick either equation you want. I'm going to use the top one because it looks easier. 2x plus y is 250. So we found out that x is 105, and so you would plug in that 105, and then you would solve again. Okay, so here's our top equation. You know that x is 105. 2 times 105 would be 210. And then your very last step to get y alone would be minus 210 minus 210. And we have y equals 250 minus 210 is 40. So the y, the number of individuals, would be 40. Okay, and they state that at the bottom. Okay, so we will do a couple more of these, see what we have time for here. Solve each system using substitution. So now we're kind of taking it out of a word problem and just, you know, looking at the steps again. So we're going to start with the first equation, and we're going to get x by itself. It's going to be pretty straightforward to get x alone, because all we have to do is minus 2y and minus 2y. So x is 8 minus 2y. Then we're going to do our substitution step. So this is equal to x. And so we're going to take that expression and plug it in for x into the second equation. So because it's equal to x, we're going to plug it in for x, or replace x with this expression. That's called the substitution step. So we have the 3. Instead of x, we're putting in this whole expression that's equal to x, 8 minus 2y. Then we have minus 4y, and then we have equals 4. So when you take this and plug it in for x, that's your substitution step. And now you just have algebra from there. So we'll start with distributing. 3 times 8 is 24. 3 times negative 2y is negative 6y. Bring down the minus 4y and the equal sign and the 4. These are like terms. We have variables and variables. So that is minus 4. We're going to just put those together, and that's going to be a negative 10y. Okay, so those are just groups, so we're getting y alone. We would do minus 24 minus 24, negative 10y. 4 minus 24 is negative 20. And then finally, divide by negative 10, divide by negative 10. Negative 20 divided by negative 10 is 2. So we know our y value is 2. Then what you do, we still want to know our x value. So we're going to go back to either equation you want. So the first one or the second one. I'm going to use the first one because it looks a little bit easier. X plus 2y equals 8. So I'm just copying that first equation. I know that y is equal to 2, so I'm going to put that into the equation. So y is 2, and I'm going to plug that in. So I have x plus 2, y is 2, so I'm here, and then I have equal sign 8. Okay, so I plugged in my y is 2, and then I'm going to keep solving. So I have x plus 2 times 2 is 4, equal sign 8, and then continuing to solve for x, I'm going to do minus 4 and minus 4, and I get x equals 8 minus 4, which is 4. So my solution, x is 4 and y is 2. So that would be my solution for that system. Number 13 at the bottom. So probably we'll just finish these three. Yeah, and maybe stop there. Solve the systems by any method. Explain why you chose that method. So we'll just solve those. I'm gonna write this up here. 13. Let me space this a little bit. Okay, so 13 is x minus 5y equals 2. And then the second one is x plus y equals 8. I'm going to just write that right here. X plus y equals 8. Okay, so if we start with our first equation right here, we're going to get x by itself. So we're going to do plus 5y and plus 5y. And we have x equals 2 plus 5y. So we got the x by itself. Then we're going to do our substitution step. This is equal to x, and so it's going to get plugged in for x. It's going to get substituted into the other equation. So x is equal to 2 plus 5y, and it's going to replace the x in that first equation. So that substitution step looks like 2 plus 5y, and then plus y, and then equals 8. Okay, so your substitution step, this is replacing the x. 2 plus 5y plus y equals 8. And now we just have to solve this equation. We have like terms, 5y plus 1y, and we're going to group those together. 5y plus 1y is 6y. And then we're going to keep solving that. So we're going to do minus 2 and minus 2. We have 6y equals 8 minus 2 is 6. And finally, divide by 6, and we get y is 1. 6 divided by 6 is 1. At this point, now that you have your y value, let me resize this if I can. So now that we know y is 1, we're going to be able to figure out our x value. And you can use either equation all the time. You can pick what you want. So this one here looks a lot easier with. And that equation is x plus y is 8. Since we found out that y is 1, we're going to put that into the formula for y equals 1. So x plus, we know that y is 1. And then we just have to solve that equation, which would be minus 1 minus 1. And we get x equals 8 minus 1 is 7. So our x value is 7, our y value is 1. Okay, that is number 13. Let's take a look at 14. This actually will be the easiest one we've done so far. So 2y equals x. And then the second equation, x minus 7y equals 10. So this one's already set up really, really nicely for substitution because we already have a variable that's isolated, that's by itself. So x is equal to 2y. And because x is equal to 2y, this is equal to x, we would be able to put it right into the formula. So we didn't really have to do a lot of algebra there at the beginning. Because this is equal to x, it can replace the x. So instead of x, I'm putting 2y, right? Since x is equal to 2y, I can just put x or 2y. So 2y minus 7y equals 10. And in solving this, these are like terms. 2y minus 7y, so 2 minus 7 is negative 5. Right? So that's going to be just combining those. 2 minus 7 is negative 5. So negative 5y equals 10. Divide by negative 5, divide by negative 5, and we get y equals 10 divided by negative 5, which is negative 2. Value. And the last part is to figure out what your x value is. And again, you can use either equation you want. I always use the one to me that looks easier, and that's the first one, 2y equals x. That looks like an easy equation to work with. I know that y is negative 2. So now I'm going to substitute again. And I have 2 times my y is -2 is equal to x. 2 times -2 is -4. And so my x value is -4. I have x is -4 and y is -2. And that would be my solution for number 14. All right. For the sake of time, because there is not a lot of time that I have left before this is going to cut off, we're going to skip 15. And this would be writing your own equation. Let's just go down to number 18. And this would be your last question. This would be a great question to pause and try. See if you can do this on your own. I'm going to start with the second equation, and I'm going to get x alone. Because I can kind of see all I have to do is plus 2y plus 2y. And then I have the x by itself. Again, if you can pause and try this, this would be really good practice to see how far you can get with this question. Okay, this is equal to x. This expression is equal to x, so it's going to go where the x is in the other equation. So we have the 2. Instead of x, we're putting this expression -4 plus 2y, since it's equal to x. I have minus y, I have an equal sign, and I have -2. And now I'm going to solve. So I'm going to distribute. 2 times -4 is -8. 2 times 2y is 4y. Minus y equals -2. These are like terms. 4y minus 1y. 4 minus 1 is 3. So I'm grouping those together. 4 minus 1 is 3. So I have 3y. Keep solving, isolating the y. I would do a +8 and +8. -2 plus 8 is 6. And finally, divide by 3, divide by 3. And we get 6 divided by 3, which is 2. Now that we know the y value is 2, we're going to go back, pick either equation you want. It doesn't matter which one. I'll do the first one this time. 2x minus y is -2. And because we know that the y is 2, we're going to plug that in. So I have 2x minus y, I now know is 2. Copy the rest of the equation, and then I keep solving. +2 plus 2. -2 plus 2 is 0. Divide by 2, divide by 2. And I get x equals 0. So that solution, x is 0, y is 2. This is just an alternate method to the graphing method that we have been using. So we did skip 16 and 17, and we did skip 15. And then on Friday, we will only just practice this method and not do anything new, so we can go over any questions that you might have. You can go ahead and turn this into Canvas now.